they just said, I'm just going to talk about some of our work that we've been doing at Salford about lateral ankle sprains, particularly from a structural and functional perspective. Before I do that, I just want to thank a lot of the people that have been involved with the research over the last few years at Salford. So we've had Bahar, who supported some of the initial data collection and is continuing to support some of the data processing that we've been doing. Rowan, who was a former PhD student of ours, and she's been quite critical in developing our ultrasound techniques. Khalid is a current PhD student and he's working on prospective design in terms of looking at lateral ankle sprains, and Rich and Chris have both been supporting some of the research as well. And finally, the Manchester Institute of Health and Performance is a sports medicine facility over in East Manchester, and some of the biomechanical data that I'll present in a bit, we were able to collect in their pretty amazing facilities and their capture hall. So ankle sprains are really common in sport. They account for about 15% of all sporting injuries. They're particularly common in court and field sports. And in particular, they have, it's kind of during the sort of movements where someone's landing or they're changing direction or they're rapidly decelerating where we see these ankle sprains. And what we can see when we look at someone sustaining an ankle sprain is we see this rapid inversion alongside rapid internal rotation, and sometimes the ankle is plantar flexed, but not always. Now, ankle sprains are seen to be quite a minor injury. Almost 50% of people who have a sprain will recover within 24 hours, and most people are back within 2 weeks once the pain and the swelling have subsided. But the concern is that is this 2 weeks enough to address the impairments associated and allow for healing of all the structures that are damaged during the sprain. If we take, say, 100 people who've had a lateral ankle sprain, a high proportion will then go on and develop chronic ankle instability, so that they have long-term impairments, such as they will complain of recurrent sprains, episodes of giving way, or feeling of instability. So there's a lot more going on here than we first think when we think of an ankle sprain. There's a lot more issues down the line that we need to consider. Now, if we take chronic ankle instability, it's not a binary sort of thing, you haven't got it or you have got it. It's on a spectrum from people on the left-hand side who have recurrent sprains and may even need surgery, to people on the right-hand side who are fully recovered, able to participate in sport as much as they want and have no issues. These are known as copers. What we've seen in the past when we've looked at the literature is a lot of people will compare chronic instability with healthy. What's starting to come out in more recent research, and what we're trying to do at Salford, is actually understand the difference between a coper and someone with chronic ankle instability. So they've both had this initial sprain, but one person's gone on to develop recurrent issues and long-term consequences, whilst the other person hasn't. And what would be interesting, what we're trying to understand, is why, what are the differences in their characteristics? And then once we understand that and we can kind of tease that out, can we then start to develop appropriate interventions for our chronic instability individuals? So from Salford's perspective, what we've kind of been focused on is we've been looking at from a structural perspective using ultrasound, and that's where Rowan's skills come in. And from a functional perspective, using 3D motion capture techniques and EMG techniques, which we'll go into in a bit. From a structural perspective to begin with, what we see is when someone sprains an ankle, they tend to injure the lateral ligaments, and in particular, they tend to injure the ATFL, which in this case is the red ligament marked on the left. And what we see is the reason it's more injured is because this is the ligament that restrains inversion, but it also has the lowest, requires the lowest load to failure. So it's almost the weakest ligament out of the three. So it's not unsurprising it gets injured mostly compared to the other two. So this is just taken from some of Rowan's PhD data, and what she did was she measured the ATFL along with some other structures, but I'll focus on the ATFL for today. And we found that there's the chronic ankle instability individuals have a thicker ATFL compared to our copers, and then compared to our healthy. And this is reflective of the healing process that the ATFL goes through, the remodeling that we see post-injury. Now, what we see, probably the higher thickness in the chronic compared to the copers, is likely because chronic individuals tend to have recurrent sprains, so there's continuous healing and remodeling going on compared to our copers who have just the one ankle sprain. What we look at when we look at using the ultrasound looking at length, the boxes on the left-hand side is the ATFL in a neutral position. There's no difference. But when we put the ankle into an inverted and plantar flex position, so we stretch it or put it under tension, which is what the boxes on the right suggest, is we see that the chronic and the coper group have longer ATFLs compared to the healthy. So there's less mechanical restraint in terms of inversion going on here, which we kind of, well, it's unexpected or expected. What the question is, we see structurally based on just the ATFL, and when Rowan's measured the other muscles around the ankle, we don't see any differences between chronic and copers. They're structurally similar, they have similar laxity, but is there something going on functionally that allows a coper to cope whilst a chronic individual develops these recurrent sprains? So the data I'm going to present today in terms of the biomechanical data is focused more on someone landing off a box. So is it, for example, this person here, a 30 centimeter box. We've used retroreflective markers to capture their motion. We've used EMGs to capture their muscle activity, and we can start to untease it. I will say the project got put on hold because of COVID, so we've got small samples at the moment and we're still processing the data, so it is completely preliminary, but it gives you a flavour of what we're seeing in our data. So if we take their time to stabilisation, so this is basically the time it takes upon landing to stabilise and remain static on that one leg. And the bottom box you see is the chronic. They take a lot longer to stabilise compared to our healthy and compared to our copers. So this tells us that functionally our chronic have some deficits. They have reduced postural stability, reduced balance going on there compared to our copers, who are able to cope with this fairly simple task. Now the question is why? Well, what we've, again, because it's still early stage and we're still processing the data, I can only show you the chronic versus the healthy. But what we've been able to do is look at the onset time of the perineals. So our main everters, our main resistors to that inversion. And we see that they switch on a lot later for our chronic compared to our healthy. So there's less time for that ankle to get into an appropriate position and start to brace for that landing. Again, hopefully at some point soon we'll have copers so we can see where they fit in, and maybe they're similar to healthy, who knows. But this kind of reflects what we see in the literature as well. So we have, in terms of the ankle, we have delayed activity, or we have changes in activity in our perineals for chronic compared to healthy. There's evidence that the chronic individuals will have weaker everters compared to copers, but also compared to healthy. But we see similarities in terms of their laxity, in terms of copers and chronic. So functionally something's going on, structurally they're similar at the ankle. But we got to remember there's a whole body going on here. It's not just the ankle, it's a whole system, and the individuals have to kind of figure out what's going on there. What we see in the literature is there's reduced strength, particularly the hip abductors. So they're weaker in the chronic compared to copers and healthy. There's reduced activity of the glutes, and again, unfortunately, these studies have only looked at chronic versus healthy. And there's altered movement patterns at the knee, hip, and ankle. So some of our preliminary data during the landing, and what we're seeing is chronics demonstrate greater inversion moments, as well as changes at the hip. And these inversion moments increase the likelihood of putting the ankle into an inverted position. So they are at more risk compared to our copers and healthy. Our copers are following similar patterns to our healthy. So that's in our frontal plane. When we look at it in the sagittal plane, what we can see, so this is a diagram of a healthy person in their landed position, roughly. And we see the blue overlay is our copers. So they're almost more extended when they land. So they have reduced hip flexion and reduced knee flexion, suggesting they're landing with a stiffer kind of stature, possibly as a way to cope, possibly to reduce their risk of sustaining an ankle sprain. But this suggests a quad heavy strategy. They're using their quads to absorb that energy and stabilize that movement. Unfortunately, with that does increase your ACL loading. So we could be seeing that our copers, yep, they may be able to cope with not having recurrent sprains, but maybe they're putting themselves at more risk. Again, we need to have caution with this data, as we've got low samples and we're still kind of figuring this out, but it is a potential hypothesis. So we may need to think about interventions for our copers and not just our chronic individuals. So just to kind of summarize kind of some of the work that we've been doing and we're continuing to try and deliver on over the next few months and so on in terms of our processing, is we see those with a history of sprains, even if their copers, have longer ATFLs. So something different structurally compared to healthy. What we could do with and what we need to start to think about is, can we look at the muscles in terms of echogenicity? Can we look at the ATFL and these ligaments in a more dynamic ultrasound perspective? And that's something we're having a look at for potential future studies. From a functional perspective, yeah, chronic have these deficits in their balance, their postural stability, and we see some evidence of neuromuscular differences. But the evidence at the moment for copers is limited, so we need to explore that further. And chronic do put themselves at risk of recurrent sprains, which kind of goes hand in hand. They complain about more sprains, whilst copers could be reducing their risk of sprains, but they could be increasing their risk of injury. So this is something we need to consider in future studies and explore further, maybe even down using more epidemiological type studies. And that's it. So thank you for listening.